only podcast. With Low Jackson, rewire the mind. Yeah, the thoughts keep flashing. 60,000 strong, we just keep on growing. Emotional intelligence, a vibe keep flowing. You only podcast. One mind, one show. Awareness in your soul, let the knowledge just grow. Keep flowing. Podcast. One mind, one show. Awareness in your soul, what to know.
What if the same spark that flickered the instant life began is pulsing in you right now? Frances Ashcroft calls it the spark of life, and she has spent her career proving just how real that spark is. From the zinc fireworks that ignite a new embryo to the quiet crackle of the heartbeat, this energy is what makes us alive.
Here's Frances Ashcroft with her informative insight.
The ATP-sensitive potassium channel, or KATP channel as it's known, plays a very important role in insulin secretion because it couples the metabolism of the cell, or glucose metabolism, to insulin release. And it does this in the following way. So when blood sugar levels are low, the metabolism of glucose, the breakdown of glucose, is very slow. And the consequence of this is that the KATP channels are open, and the movement of potassium ions out of the cell through this pore generates a negative membrane potential. And what this does is to keep calcium channels, another type of ion channel in the cell, closed. And because calcium has to come into the cell to trigger insulin secretion, this means that there is no insulin secretion. So when metabolism is low, the KATP channels are open and there's no insulin secretion, as you see. However, when your blood sugar level goes up, glucose is taken up, metabolized, broken down by the cell to produce a chemical which is known as ATP. And ATP binds to the potassium channels and shuts them. And the consequence of that is that the membrane drifts to a more positive potential and the calcium channels then open. And so calcium can flood into the cell and stimulate insulin secretion. So when metabolism is high due to elevated blood glucose, the potassium channels are closed and insulin is released. Now you can immediately see that if for any reason the channels didn't close in response to elevation of ATP, in response to elevation of glucose, then no insulin would be released and you'd get diabetes. And this is exactly what happens with certain mutations which are found in either of the two subunits of the KATP channel. What they do is they prevent a cell from responding to elevated ATP. And the consequence of that is that the channel never closes despite very high blood sugar level. And that means no insulin is released and the patient gets neonatal diabetes.
For my young listeners, that spark is discovery itself. It's the electricity behind your first text message, your fast reflex, your quickest thought. For my older listeners, it's a reminder the very same currents that fired in your first kiss or your first memory are still alive and well in your brain today. That spark never grows old. Now, who is Frances Ashcroft? She's one of Britain's most respected scientists, a professor of psychology at Oxford University, a researcher who cracks some of the greatest mysteries of how our cells make electricity. Her work on ion channels even reshaped how we understand diabetes. She showed how defects in these tiny gates can disrupt insulin release. So when Ashcroft writes about the spark of life, she isn't waxing poetry, she's giving us science straight from the laboratory. And what a laboratory it is. Every nerve impulse you've ever felt, every memory you've ever stored, come down to ion channels, microscopic doors in your cells that open and close in less than a thousandth of a second.
Here's Frances Ashcroft with her informative insight.
And it's also different ion channels are also involved in plant fertilization. I don't know if you know, but here is the pollen grain extending a pollen tube. It has to grow down the whole of the long female apparatus down towards the egg. It carries the sperm with it. And when it gets there, what happens is cells that surround the female egg release a chemical known as, which diffuses to the end of the pollen tube, opens a an ion channel there and causes it to swell up and burst and liberate the sperm so that they can then fertilize the egg. We also use ion channels as lethal weapon. An example, so what happens is this is a T lymphocyte killing another cell, another blood cell that's infected with bacteria. What happens is they secrete giant channels, go and plug themselves into the membrane of the target cell and form a huge great hole like this, which allows loads of the important constituents of the cell cytoplasm to be released from the cell, and the cell simply bursts and dies. And this one, Staphylococcus aureus alpha toxin, is particularly nasty because it causes blood poisoning if it gets into your red blood cells.
Here's a stat to fry your mental circuit. A single nerve impulse lasts just 1 millisecond, but millions of ions cross through thousands of channels. Multiply that across the 86 billion neurons in your brain, and you're carrying out more electrical events each second than all the messages on the entire internet combined. If you could harness your body's own electricity, you could light a small bulb just by sitting still. And then there's the most dazzling example, the zinc spark. At fertilization, the human egg releases an astonishing 12 billion zinc atoms in minutes. That's not a metaphor. It's a literal light show. Captured by scientists with high-powered microscopes, the zinc spark transforms the egg's surface, sealing it off from other sperm. It's life's first act of self-protection, nature's way of saying one ticket only, no re-entry.
This is a discovery emerging in real time, and I have a few new images hot out of the lab. This is a zinc spark occurring in real time, or in about 10x speed. But we now are looking at it in 3 dimensions. But what you can see is the cell lights up, and you see that the zinc sparks occur as these yellow flashes, almost like sunspots. And then as the brightness fades inside, what you'll see and the yellow comes in, that's an overlap of the red and the green. Then you see the red spark moving away from the cell. So we've literally caught it in flagranta. We've caught the event that the sperm introduces, perhaps the most fundamental change in physiology of the egg, that now sends information careening throughout the cell and announces that we have to change our game plan. After all, the cell was dormant for sometimes up to 40 years, and now it has to completely retool.
Because that spark, that first spark, is the same force running through your body at this very moment. The beat of your heart, the idea forming in your mind right now, all of it is part of the same story Ashcroft spent decades revealing. What I love is how Ashcroft makes the invisible visible. She compares ion channels to tiny electrical switches in a vast city. Open one and a neuron fires like a street lamp flickering on. Open millions and a thought emerges. This is a woman who took the dry machinery of biology and made it sing like poetry. Modern science is catching up to her vision.
Here's Frances Ashcroft with her informative insight.
I wonder if you've wondered why chili peppers taste hot. Well, it's because they contain a chemical known as capsaicin, which works on ion channels in your mouth. And this is Wilbur Scoville, who calibrated the potency of chili peppers by diluting them and then seeing how much effect they had when placed on the tip of the tongue. And you see, if you have just a very green bell pepper, there's really no Scoville units. But as you go hotter and hotter and hotter, you get many, many more of them, right up to the US grade pepper spray, which is used in warfare and, unfortunately, for controlling citizens. And it was David Julian who showed that the capsaicin receptor is actually an ion channel. It's here, and it's not only sensitive to chili pepper, to capsaicin, it's also sensitive to noxious heat. And in fact, it turns out now that there's a whole range of these channels, each of which is sensitive to a different thermal scale, right down here from the ones which are sensitive to cold and also to mint and eucalyptus, which is why they taste cool, up to here with the ones that are affected by heat.
In 2024, researchers discovered that applying finely tuned electrical currents could supercharge one natural killer cell, the assassins of the immune system, against aggressive cancers like glioblastoma. That's electricity saving lives. Stanford scientists found that some brain tumors literally wire themselves into our neural circuit, hijacking signals to grow faster. Imagine that a tumor stealing the spark of life to feed itself. And in another twist of fate, researchers found that glioblastoma soak up 10 times more zinc than normal brain cells, exploiting a transporter called ZIP4. Block that spark, the cancer's fire dims. It's like our cells are running a nightclub. Sodium wants in, potassium wants in. Calcium barges through the VIP section. And zinc, waits until the moment's just right. Then throws confetti and shuts the place down. Meanwhile, neurons fire at speeds of 120 meters per second. Audience, that's faster than a major league fastball, and without any performance enhancement. Your brain doesn't even need Gatorade. Frances Ashcroft knew early on that these sparks weren't just technical details, they were life itself. In fact, she once said her fascination began as a child, watching lightning and wondering if something similar happened inside us. That curiosity led her to a career unraveling how electrical currents make muscles contract, hearts beat, and thoughts emerge. She turned invisible whispers into measurable science. And friends, our community here is doing something similar. Every week, your downloads, your shares, your listens, they are sparking that light. This show is much, much brighter. Thank you to all of you who follow, especially those fan members sending kind notes. Your curiosity proves that wonder is ageless. This podcast is growing, and it's because of you. So let me return once more to the hook. The spark that bursts when life began still flickers in you today. It glows in your nerves, your heartbeat, your laughter. Frances Ashcroft gave us the language to see it, to measure it, honor it. Once you understand it, you cannot unsee it. The universe wrote its first story in electricity, and that story is still unfolding inside of you. Stay curious, stay electrified, and please, always stay tuned. You Only Podcast.